Did complex life on Earth start twice? A group of scientists think so. This is a controversial claim, but one that could rewrite the textbooks and teach us a lot about the evolution of life on our planet and possibly elsewhere. The standard textbook story goes like this. The first microorganisms appeared about 3.5 billion years ago. Then, for the next 2 billion years, basically nothing happened. The planet was populated by small cells without nuclei who were waiting for their turn. It wasn't until about 600 million years ago that cells began to organize and give rise to increasingly larger organisms with increasing complexity. Fast forward 600 million years, and here we are on YouTube, the logical endpoint of intelligent life. But maybe those 2 billion years weren't quite as boring as we thought. Because if this evidence is real, the evolutionary timeline is completely wrong. And there's something even more frightening. Why did this first attempt at complex life fail? A group of researchers in France has been arguing for more than a decade that life actually made a much earlier attempt at complexity. But that didn't work out for some reason. They've now presented new evidence for this claim. Fossils that date back to more than 2 billion years ago, and they say these are evidence of organisms at least a centimeter in size. If they're right, this would be big news. Also depressing. I mean, imagine how far along we'd be if we'd had 1 billion more years to understand the YouTube algorithm. This new evidence comes from black shale they found in Gabon. These rocks have been dated to about 2.1 billion years ago, so that's long, long before we thought complex life existed. In these rocks they found shapes about a centimeter in size that are made of pyrite with arsenic inside. Pyrite is a compound made of sulfur and iron that's produced when microbes break down organic matter, but it can also occur naturally, so that doesn't tell us much. Their smoking gun evidence is the arsenic, because they say arsenic would have been toxic to these early forms of life. However, they would have learned to isolate it. So when the organism died and was broken down by smaller organisms, there'd be concentrated blobs of arsenic left where it had isolated the toxin. And this is exactly what they see. It's not just that. They say this finding is extra hard to explain by non-living processes because the surrounding rocks are different in composition. It looks like something dragged itself there, then died and left behind this trace. Yes, it's something with life and something with arsenic. But no, this isn't an arsenic life story. This organism, if it existed, wasn't living on arsenic. Rather, it was trying to limit the damage from it. The new story here is that if this was an organism, it was dramatically larger than anything we thought existed at the time, and then it went extinct. I have to warn you, though, that most geologists are not convinced by this evidence, at least not yet. They say there could be chemical mechanisms to grow structures like this without any living being in the process, but they don't actually know how this would work. Others say these might be deposits from fluids. Others say that yes, maybe it was actually organic, but it just happened to be a big bunch of single-cell organisms sitting in one place called a microbial mat. They survive until today, but now we call them carpets. You know, this is a super controversial claim, but it doesn't look like anyone has a better explanation. What would it mean if these guys were correct and complex life arose so much earlier? It would mean that the emergence of life is both easier and more difficult than we thought. It can happen faster, yet it's also more fragile. I find this a fascinating development, not just because it tells us something about our own origins, but because it can tell us something about the likelihood of life out there on other planets. Maybe we're not as rare and unique as we like to think. Rather, we're the latecomers, and all the other civilizations are 1 billion years ahead of us. Is it a surprise, then, that we can't find any evidence of extraterrestrial life? To them, we might be about as interesting as microbial mats are to us. Then again, we value some of our microbes, don't we? I mean, where would we be without sourdough and cheese? So maybe there's hope for us. There's also a deeper lesson in this. The right way to deal with toxicity is to isolate the compounds and let them fossilize. Now, let's think about what this discovery means in the big picture. If there were centimeter-sized complex organisms 2.1 billion years ago, this challenges fundamental assumptions of our evolutionary theory. According to the Standard Model, complexity is a gradual, slow process. The transition from simple cells to multicellular life took billions of years. But if these fossils are real, complexity can emerge much earlier. So why did it disappear for a billion years? There are two possibilities. One, complex life forms more easily but is very fragile. Or two, environmental conditions back then were completely different. If the Gabon fossils are real, it shows Earth experienced its first mass extinction, not just the extinction of individual species, the extinction of the entire category of complex life. How could this happen? There are several theories. Oxygen crisis. 2.4 billion years ago, cyanobacteria started pumping oxygen into the atmosphere. For most life forms, this was poison. Maybe complex organisms died from oxygen poisoning. Climate change, the snowball Earth hypothesis, the planet becoming completely covered in ice. Complex life couldn't survive. Chemical change, dramatic change in ocean chemistry. Even organisms that could isolate arsenic levels couldn't survive. Whatever it was, the result is clear. Earth's first complex civilization was completely wiped out, and then evolution had to start over from scratch. This discovery adds a new dimension to the Fermi Paradox. Fermi's original question was, where is everyone? If the universe should be full of life, why don't we see aliens? But if complex life already emerged once and was destroyed, the answer might be different. Maybe most planets in the universe experience similar cycles. 1. Simple life evolves. 2. Complex life emerges. 3. Environmental catastrophe occurs. 4. Everything resets. 5. Starts again. In this case, most planets are constantly in restart mode. Only the very lucky ones, like us, succeed on the second try. This means intelligent life is very new by universe standards. Most civilizations are still in the first attempt phase. If Earth really is the second attempt at complex life, what does this mean for us? Why did the first civilization fail? This question isn't just academic, because we might risk making the same mistake. The first civilization probably couldn't adapt to environmental changes, or it poisoned its own environment so much that it became unlivable. Does this sound familiar? Climate change, pollution, microplastics, radioactive waste. We're poisoning our own environment. Maybe this time we should try to be different, because there's no guarantee the planet will give us a third chance. The most important message of the Gabon fossils might be this: complex life is fragile, and second chances aren't guaranteed. Of course, I can't say this theory has wide acceptance in the scientific community. Most paleontologists are skeptical. They say the evidence isn't conclusive yet. But this is normal. Paradigm-shifting discoveries always meet resistance. Wegener's continental drift theory wasn't accepted for decades. The problem is, alternative explanations for these fossils are also problematic. You say chemical process, but which chemical process? The mechanism isn't clear. You say fluid precipitation, but then why only in that specific region? And why is the arsenic concentration so high? You say microbial mat, but no known mat forms structures this large. No alternative explanation satisfactorily explains all the evidence. What's needed to resolve this debate? More fossils, from Gabon and elsewhere. If these organisms really existed, they shouldn't have been limited to single examples. Better dating techniques. 2.1 billion years is a very long time. More precise dating is needed. More detailed analysis of the arsenic isolation mechanism. How do modern organisms deal with arsenic? Did these ancient organisms use the same method? And perhaps most importantly, we need to understand why these organisms went extinct, because the answer to this question could be critical for modern civilization. Maybe the biggest lesson of this story is this: life is very strong, but also very fragile. It can survive for billions of years, but a single environmental change can end everything. Complexity isn't guaranteed. Progress isn't guaranteed. Civilization isn't guaranteed. Maybe Earth's greatest achievement isn't creating complex life once, it's creating it twice. And maybe our greatest responsibility is not to waste this second chance, because if the Gabon fossils are true, there might not be a third chance, or even if there is, we might have to wait another billion years. So treat your microbes well, keep your environment clean, and remember, we're not just the latest, we're probably the second attempt, and second attempts are much more valuable. Thanks for watching. See you tomorrow.